class. It's nice to meet you once again. So today we'll be looking at metals and non-metals. Like I promised in the last lesson, we'll be treating this topic today. How do you identify a metal? And how can you tell if an element is a non-metal? These are some of the things we'll be observing in the lesson today. We'll be able to state the differences and distinguish between what a metal is and what a non-metal is. We'll also be looking at the physical and chemical properties of metals generally. Okay. In our last class, when we treated the periodic table, if you have not seen that video, please, you can go back and watch that video. In our last class, we explained in detail why we have more metals on the periodic table than non-metals. As a matter of fact, we have 75 metals on the periodic table and the rest non-metals. But of this so much metals we have, only very few are useful to us because most of these metals are reactive. These few that are very useful to us consist of iron, used in making steel, and we have some that are not reactive. These ones are known as gold, silver, and platinum. They are expensive, use them to store wealth and value, and we also use them for ornamental purpose. Metals generally are solids, okay, except for one particular one at room temperature, and that is mercury. Mercury is liquid at room temperature. It is the only metal that is a liquid at room temperature. So you have to take note of that all metals are solid except mercury, which is liquid at room temperature. So all metals are solids. Some of the physical properties of metals generally, as one basically, is that they are good conductors of electricity. They are good conductors of electricity. They are malleable, they are lustrous. When we say they are lustrous, it means they are shining. Non-metals are not. Okay? But there are exceptions to this. Graphite and iodine has this lustrous surface too. Okay? But the rest are dull in appearance. In terms of conductivity, the metals are good conductors. They are good conductors of electricity. Okay, but non-metals are poor conductors, except one again, which is graphite. Okay, I know you're wondering why mentioned graphite. Graphite is not on the periodic table. Of course, graphite is a form of carbon. Okay, so you may not find graphite on the periodic table, but it actually contains carbon. So it's represented as carbon because it's an allotrope of carbon. Okay, so when we treat allotropy, you will understand that elements also exhibit different forms. Okay, so graphite is just one form of carbon. All right, so malleability means metals can be beaten into shape. You can beat metals into any shape you want. Okay, like your baking pan. So it comes in different shapes. Okay, your car, comes with different design because metals can be bent, can be, beaten into different shapes. Okay, but non-metals, no. They are brittle, and when you try to make them bend, they break in the process. Okay, when you hammer them. And then ductility has to do with being able to be drawn into wires. Only metals can be easily drawn into wires. Examples of such metals are copper, aluminum, and the likes. Okay. Now, Another difference between metals and non-metals is that metals have high density, but non-metals have low density. So metals also, when you look at the chemical properties, metals generally react with oxygen. Let's take, for example, sodium. Sodium reacts with oxygen to produce sodium oxide. Okay, this is what makes sodium to tarnish in the process. Sodium tarnishes in the process of producing oxide. Okay, because sodium is very reactive. When this reaction takes place, you find out that its lustrous and shiny surface will begin to fade because an oxide is formed. Okay, so metals generally react with atmospheric oxygen to form metallic oxide. When these oxides to react with acid, they neutralize an acid in the process. So that means metal oxides are basic oxides. Okay, and we can technically say metals form basic oxides with oxygen. Okay, so whenever they react with oxygen, they form a basic oxide that can neutralize an acid. Okay, so these are the major differences between metals and non-metals. Now look at the trend, the reactivity series of metals. Metals generally, when you look at your periodic table, when you move from group one are the most reactive metals. So as you move away from group one, the reactivity of metals decreases. So that means the most reactive is group one, then group two, and then it goes down to group three. Okay, so the reactivity reduces in that way. A good way to test for that is the use of water. When metals like group one metals react to water, they react violently with water. In fact, most of them catch fire in the process. But group two will react mildly with water. Group three will not. Okay, but we only react with water at a higher temperature. So that already suggests that group one is more reactive to, then group two is more reactive than group three. This reactivity series is quite different from non-metals. For non-metals, as you move up from group 5 to 7, reactivity increases. So that means group 7 is the most reactive non-metals we have, while group 1 are the most reactive metals that we have, which means the most reactive elements, be it metals or non-metals, are towards the extreme ends of your periodic table. To the extreme left, you have the most reactive metals, and to almost the extreme right, because we have group 0 after group 7. Okay, that is where we find the most reactive non-metals. So that brings us to the end of the class today. If you like this video, please kindly click the like button. If you want more of this video, ensure you subscribe. Hit the button below this video, subscribe to get more insight into topics that concern chemistry and other subjects. At this juncture, I would like to say bye till we meet again.